Okay, so we only have about 2 hours together. So what we're going to focus on are some applied skills in organization, documentation, automation, and dissemination as they relate to reproducibility, and specifically as they relate to publishing your data and code. So focusing on that publication step. And part of that is because a lot of the things that you can do at that step, you can actually apply at any point throughout your workflow. And also to emphasize the point that it's never too late to make your work a little bit more reproducible. So even if you haven't been, documenting as you go along, you can create a little bit of documentation, for example, at the end, and help someone else to understand what you did and to build upon your work. So this is our general aim for today. My greatest nemesis is time. So I've tried to cut out everything that is not absolutely necessary. But if I'm starting to rush through something that you yourself think is very valuable for you, raise your hand and let me know, or just yell out, I'd like to hear more about that, and we'll spend a little bit more time on it. I've created the slide deck as a bit of a resource for you. So some of the things I might go through quickly, but it will have on it links to additional resources, additional reading, additional explanations, so you can dive deeper into that on your own. And always feel free to email me if you have questions afterwards. I'll be around for another half hour or so afterwards as well, if you have additional questions. But generally speaking, we're going to focus on some hands-on work. So we're going to do exercises together, which is why it's good to have a laptop to work through, and why we're going to create a little bit of data so we can actually get our hands a little bit dirty. That also means that it's a bit of a messier workshop, because people will always come up with issues with compatibility or technology and things like that. But I think it's worth it because a lot of these skills are easier to try out on your own if you've actually tried it out with data, beforehand. So hopefully you'll find that useful. But again, I have surveys there in the back, and I really appreciate feedback on how you think the workshop can improve. I apply that every time I run it. So I'm trying to keep this as relevant as possible. All right, so everyone's settled in, so I'm going to force you to stand up. How mean of me. We're going to do an icebreaker. So everyone stand up. We're going to form a line. The person who stands here is the person who has touched code for the research most recently. Okay? And the person back here, where Amy is the person who has never coded before and doesn't even know what code is. And everyone in the middle is a spectrum along the way. So we're trying to get a sense of how much coding we've done. You have to talk to the people around you and find out when they've coded last. When was the last time you coded?
I think a couple of weeks ago.
Couple weeks ago, right here.
Yesterday afternoon.
Yesterday afternoon. You go down that way. Yesterday. You've got to figure out what time now. See which order you're going to go.
3 o'clock.
So
No, before that? After that.
What week goes here?
The afternoon.
Okay.
Never use
So we're right here
those.
somewhere.
They're over here. Down here.
Center.
Okay.
That's
Code
cool.
house.
Yeah, because I code every day.
Yeah.
3 p.m. yesterday.
Okay. When did you do last code? Last week. And you were a few weeks ago? Yeah, okay.
Today morning in Julia.
Oh, there you go. I had somebody who was coding as this was going on, and then I had to force them up here to the very front. Okay, so part of this is to force you to actually get to know each other a little bit, but also take a look around to the people that have some experience coding and those that are new to it. We're going to help each other out as we go through the workshop. Because of the number of people in the room, it's sometimes difficult for me to be able to get and troubleshoot everybody without, holding some of the other people behind. So what works best is we'll use these sticky notes that I gave you to communicate where you're at in the workshop exercises. When you finish the workshop exercise, you'll switch your sticky note to green. You don't have to memorize this, I'll tell you to do it. And then you can take a look around and see if someone around you is still working on it and might need some help. So I invite those with a little bit more experience to help out those without as much experience, and that will help us all kind of move through the exercises together. Awesome, thank you. I promise I won't make you stand up again.
I have to stand on my knees.
Oh, it's fine. It's fine.
What's that? Oh, I am! You're right. Okay, so let's start with your thoughts. You're here at a reproducibility workshop. You probably have some thoughts about reproducibility, as basic as they might be. So what, in your opinion, do you believe that there is a reproducibility crisis in your discipline? Raise your hand if you think that there is a major crisis in your discipline. Raise your hand if you think there's a slight crisis. Okay. Raise your hand if you don't know. And raise your hand if you think there's no crisis at all. Anybody? Here. It does happen sometimes. And it's always interesting to have someone in the room. So that's pretty similar to the researcher community in general, right? Most people do think that there's an issue, there's a problem. There's some disagreement about how urgent it might be. But this is something that's on everyone's radar, and now we're trying to think about, what do we do next? But there's another way to frame this issue. Raise your hand if you've ever failed to reproduce the experiment of someone else. Oh, no? Wow, you guys have really good colleagues. Oh, you have, yeah. Now raise your hand if you've ever failed to reproduce some work that you yourself have created a few years later, a few months later. Gone back and tried to make sense of it. See, that is a very common problem in research, right? We work on a project, we move on to another project. For some reason, we've got to go back, we've got to understand what we did, and it can be very time-consuming to recreate that, the results we had before. And all of these things that we're going to talk about today, about steps you can take to improve reproducibility, they benefit ourselves first, because our most likely collaborator is our own selves in the future, right? So you can think about this as an issue that improves science, improves research, all that sort of thing. That's great. But the real motivator, I think, is to be able to improve our own documentation, our own work, in a way that makes it easier for us to work more efficiently. And the side benefit of all of that is it also makes it more reproducible and better for research in general. So think about those things that benefit yourself first, that we go over, and adopt those first. And don't worry about, trying to achieve some sort of high and mighty gold standard of reproducibility right off the bat. Think about those things that benefit you, that will make it easier for you to reproduce your own work, and those things will also make it easier for other people to reproduce your work. So I don't like to think about it as a crisis. I like to think about this as an opportunity. We now have a greater understanding about the reliability of published research. There's things we've been doing systematically that have introduced bias, that have made it likely that we'll be missing important information, that makes it hard for other people to build upon previously published work. So now that we know that, we can use technology, we can use that new understanding about the body of research to improve how we do it in the future. So this is an opportunity to accelerate research, to accelerate human knowledge by learning from the past. So I think it is beneficial to not, shout from the rooftops, to not finger point, to blame people. This is rooted in normative behavior that well-meaning researchers have done, and now we know better, and let's work together to, do better in the future. Any questions so far? So I'm not going to spend a lot of time on definitions. There is a lot of diversity in how reproducibility is defined from one discipline to another. I think it's important as a group when we have these sort of conversations to just state our definitions from the beginning so we're all on the same page and we can move forward productively. So this workshop is focusing on computational reproducibility, which is a subset of reproducibility as a whole. Essentially, computational reproducibility is just taking someone's data and their methods, such as their code, rerunning it, and being able to get the same numbers, figures, tables as were published by the original author in their article. So as you can see, it's a basic, more limited form of reproducibility. Versus, for example, empirical reproducibility, where you might rerun an entire study or an entire experiment, start to finish, and try and reproduce the results. Welcome.
Thanks.
The reason we focus on this is partly because the focus of this workshop is on code and data and reproducible publication, but also because it's the foundation upon which all other reproducibility is built. In order to rerun someone's experiment, you have to know their methods. And an important part of methods in research today is the code and the data. Almost every researcher is using software or code in their research. There are very, very few exceptions to that. So having to document and share this information alongside the article is essential. So as you can see, this is a quote from some of the founders of the idea of reproducibility, Buckheidt and Denoho. And they make the point that when we publish an article to communicate our research, it's actually just an advertisement about what we did. So it's a signal to our peers, here's what we did, here's what's important. But the actual research that you did includes all of those methods, everything that took you from that raw data all the way to those figures. The code, the data, the methods, that is actually the research itself. And we need to be able to document that in a way that allows someone else to rerun that themselves. Any questions? Welcome. So as you can see from this slide, this was published in Nature a few years ago. It's the same survey of researchers just sort of reporting back what they think the issue is in reproducibility. One of the important barriers to reproducibility is missing methods and missing code. And that is the main barrier to computational reproducibility. It's also something that individual researchers can tackle. So there's a lot of things here that are systemic, that require a change in incentives, require a change in publishing behaviors and things like that. But we want to focus on those things that we can do as individual researchers ourselves to improve reproducibility, because these other things require, larger initiatives and coordination in order to improve. Also important, but you can't really tackle them in 2 hours in a room in a workshop. So there's a lot of guidance available right now on best practices in reproducibility, and I highly recommend you do a little bit of exploring to find out what guidance is appropriate to your discipline and appropriate to your methods. We're kind of living in a golden age of guidance right now in terms of reproducible best practices. But one thing that you'll find as you go through a lot of this guidance, that the 4 facets of reproducibility, these 4 themes, will come up over and over and over again. And that's because the actual methods that we use as researchers are very diverse, but the things that make those methods more reproducible are the same. Good organization, documentation, automation, and dissemination. So this is an example of a free resource. It's a Git book called The Practice of Reproducible Research. One of the repositories I'll get you to go to later to copy for yourself will have all of this, this Git book and 2 other resources there for you, so you'll have those. But what's nice about this particular resource is that, for one thing, it's designed for people new to this, so it starts you from the very beginning, as you can see here. This paragraph covers, just in one paragraph, the basics of what we all need to be doing as researchers to improve our computational reproducibility. But the real benefit to this particular resource is that it's filled with case studies. So it's one thing to say that you should create metadata, but it's another thing to actually figure out what that means for your own research and your own discipline. So these case studies help bridge that gap between theory and practice, and helps you to see how real researchers are tackling these issues, because it is sort of a evolving world, right? We're all trying to figure out what best practices are, and it all starts with some examples. And then eventually those will become community norms, and eventually those will become actual standards. But we're, you know, early in that process for most of our disciplines right now. So having case studies is really helpful. So the other thing to keep in mind is that all of these steps towards reproducibility, it's not an all or nothing situation. You don't have to take either all. Yeah.
Can you just check, has anybody gotten into the slides?
I think I have.
Oh,
Oh, it's working now? Okay. Because we were having two problems over here. I just wanted to make sure
yeah.
if anybody else.
Was it access denied or what was it?
No, I think it was maybe just the typo. It
The
doesn't work
worst
for
kind
me.
of problem is an
Okay.
inconsistent problem.
So if you want to check here.
Okay. Yeah, so it's important to not think of this as an all or nothing situation where you either adopt all of the best practices or you're lost to being a terrible researcher who should be shamed. It's not the situation that we're dealing with. We're dealing with a spectrum, an ever-evolving set of best practices as technology improves, as we understand a little bit better about how we should be spending our time to make our research more reproducible. So it's important to think about these best practices as a spectrum. So every step that you take to improve the reproducibility of your work will push your research down that spectrum towards the gold standard of full reproducibility or full replicability, depending on which definitions you're using. So pick those best practices that are most helpful to you and your lab and your collaborators first, and it pushes you along. And every time you start a new project, see if there's new best practices you can adopt. And then we will all, as a community, be moving towards that gold standard. So today we're going to focus on publishing a reproducible document. The reason I do that is because I ran these for a few years now and was focusing on the entire workflow. But there's a few problems with that. One is timing. People are coming in here oftentimes in the middle of a project and telling them that they should have, created and published a protocol at the beginning of their study is not helpful for them. So these things that you can do before publication can actually be applied throughout the whole workflow, but it also signals that it's never too late to make your research more reproducible. If you haven't been documenting things throughout your whole workflow, you can create some documentation to accompany your publication that does budget down that spectrum towards greater reproducibility. So we're going to focus on very practical things, very practical exercises you can apply to your data and code at any point in your project, including at publication, in order to make it easier for someone to easily reuse your methods and replicate your tables, your figures, your results. Okay, so as I said before, we're going to use these sticky notes to communicate where we're at in the exercises. And if you finish an exercise, take a look around and see if someone around you might need a little bit of help. So for now, everyone put up a pink sticky on their laptop. And that's to signal that we're about to start an exercise and that you're in the process of going through it. When you finish an exercise, you'll switch it to a green sticky to signal that you either have finished it or you just don't have any questions and you get it. And do you have a laptop? We have some here. Are you sure?
Yeah, I'm just gonna watch.
Okay. We do have them though.
She's getting you one.
She's getting you one anyway. She just refused.
Jenny has them. You don't have to use it, but it's kind of a hands-on.
I know, I read everything before. I thought I'd just watch it more.
Okay.
So I didn't bring my
Yeah, actually most people in the room didn't. So you're in the same boat. Yeah. Cool. Okay, so what we're going to do first, because most of you are hoping to use the example data and code, we're going to create some data. So you should have a selection of candy. If you don't have a selection of candy, raise your hand. Anyone not have candy? You don't have candy? I'll give you one. Hey, yeah, that's quite a selection, isn't it? You're going to want better candy than that. Okay. So what we're going to do is take a look at the candy selection you have and then rate how happy you are with it from 1, which is very unhappy, to 10, which is like enthusiastic. It's the best selection of candy you have ever seen. So then what we're going to do is go into this Google form here, and this is why I wanted you to have the slide deck open. And you're going to put your name. You're going to put trade number 0. This is pre-trading candy happiness. Okay? This is real science. And then you're going to rate how happy you are with your candy. And click submit. So once you've done that, switch your sticky to green. So you're doing it for the whole selection of candy. So 1 rating for the whole selection.
It's a general state of happiness, but it's your happiness towards this
I had a problem with this before with someone in the workshop that didn't like candy. It was just 0. Just not pleased with the candy.
outliers.
Yeah, exactly.
What's the trade number?
So yeah, trade number is, we're going to do this a few times. So this is pre-trade, so it's 0. Yep. So,
IWDYY.
oh, do you have the, oh, you mean this, IW capital D V Y, right? Yep, DVY. So once you've successfully done that, switch your sticky to green.
Yeah. So you have to, what slide was the link on?
Yep. It's on slide 16. Don't eat your candy. It's very tempting. Another thing that has happened. People that got a selection of candy and ate it all before this point. So you think about how much candy was consumed in half an hour. Okay, so I've seen some green stickies. How's it going? Trade number is yeah, trade number.
I'm gonna have to go to IT to fix that.
You're gonna have to go to them and say, can I have a
It just closed out Chrome.
like this?
Yeah, I guess.
Also, while this is going on, feel free to get snacks, coffee. There's so much there. That's the hard part. I think you like what you have, but then if you big with somebody, you're going to have to give up what you like.
Okay, cool.
Now find one. Okay, everyone put up your pink sticky. And pick one trading partner, only one. And trade the candy you don't like for the candy that you do like. Okay? When you're finished with that, it's time to go back into the Google form, put your name in the same way you did before, trade 1 this time, and your happiness. Okay? When you're done, switch it to green. If you have questions, let me know. Yeah. You have, well, if you don't want to trade, if you're happy already, you're good. Yeah. Trade 1 this
You want to
time.
get on this, we do a 3-way trade.
Oh, sorry. When you're filling out the form, it's trade
Got
1.
lots of chocolate. Yeah, I get some chocolate.
But, oh yeah, only trade with one person.
Or is it 1-to-1?
Any number of items.
We can do any number of trades here?
Any number of trades
How many
with
chocolates?
only one person.
How many?
Yeah, I want chocolate.
You don't know how your values.
We need a trader. Okay.
I'll trade.
Let me trade with you.
Me too.
I'd be willing to trade. Would you have chocolates?
I
Yeah,
had
some chocolate.
What you want?
Oh, you have some. I don't have any. You have a lot.
Yeah.
I don't think you like a lot. Maybe I want like a big.
Yeah?
Yeah, maybe I try this one because I have two of these. Okay.
I'm happy. I like candy. Okay.
And before you leave, you should take all of that
Thanks.
Okay, so anyone have questions? I've got green stickies here. Green stickies. Are you guys, you didn't trade. Yeah. You're just a happy person.
Yeah, I think that's
Okay, you've traded, and everyone has entered into the Google form for trade 1, their new happiness, right? Candy selection happiness, not like life happiness. Okay, so pink stickies up again. Okay, so the last thing is a free-for-all. Everybody trades with everybody else to see if you can get a better selection of candy. Okay? So we're going to fill out the Google form again. When you finish filling out your Google form with trade number 2, switch your sticky to green, and then also we'll take a 5-minute break, okay? So,
Who wants 3 Musketeers?
free trade.
3 Musketeers?
Yeah.
Yeah, I want to trade it. What do you have? Who wants it?
You don't like candy? Oh, I know, like, yeah, this always happens. There's somebody who doesn't like candy. That we have here when they have less candy.
I like how you have now like Skittles and chocolate. It's like if my kids were in the room, they'd be all over the Skittles. But I'm noticing a tendency for people to want those chocolates in this demographic.
Skittles are
Some people really love Skittles.
April, this is Eric.
Hi.
He's the numerical and spatial data librarian at Miami University.
No problem. Yes, exactly. It's very important. Then if people zone out, they can always go back and see something. Yeah.
So you represent just this region, or?
All of the world. Yeah, I travel. Well, mostly just the U.S. now. Occasionally to Canada.
I ended up with so much candy.
Yeah, it's fun.
Your title is education
Director of Scientific Outreach. Yeah.
I'm looking for a new job in reproducibility.
Well, you are. We're hiring. We will talk about this later.
Okay,
This is great. Good to know. Okay, so everybody has done their trade. Switch to green if you have entered in your Google form your happiness level for trade 2. Green, green, green. Okay, so we're going to take a 5-minute break. So we'll come back at 10:40. Okay, so do what you need to do. Drink some coffee, drink some water, and we'll come back. We'll actually start to dive into the data and the code to do the fun stuff. And you can eat the candy now.
or stockpile it for Halloween.
Or stockpile it. Yeah, exactly. I'm so lucky that it's Halloween because it's like everything's little packages, tiny little bits of candy.
And everybody get your obligatory bagel or croissant or pastry and a cup of coffee.
Yes, please.
And what department are you? Are you in engineering? Environmental engineering? Who's your PI or are you the PI? Okay. Have we worked with you before? Oh, a lot of times. I'm sorry. But I think when I see you, like your hair, you do get kind of different. That's what's throwing me off today. That's the difference. Yeah.
Oh, backside.
Backside, yeah. So. I'm trying to remember the other student who was in the lab. Did you get a replacement for this? senior person guiding these people through the process. Oh no.
It's similar research, but they have a different thing that they analyze. We can discuss it. I think he also uses some of the things like water, just to check the needs of the consumption.
Somehow I remember the juju, but I told you. Yeah. I'm pulling it back. I had a terrible memory. I'm embarrassed actually. So I pulled that part out. So have you ever used Octave?
I want to put my name the first time, but I have only two.
This one? I believe is
Yes.
What's your version?
Nuria.
Probably not.
Nuria. Yes.
Okay, perfect. Thank you.
Before he left, all the students, when they come back from school, they're like, that's what people are working on today. So
Oh, really?
try to get used to it. That's why it's school will show you an effect on every day. Since R is open source, some people are not very one organization and open source might not use that. So in the end, you still have to learn whatever language.
I think that, like, if you learn, if you're learning something, there's going to be some transferable knowledge. I mean, it's not specific.
It's not specific, it's just,
Yeah.
it's just the way that language operates.
Right.
Once you know what you want to do, just learn how to operate. From class, you have to make sure that, oh, I should say it's not going to work.
So the gentleman over there with red hair, with green shirt, he's our new data visualization specialist, and he's very highly focused on R, so if you need it. Yes. Oh, you know? Okay. Amazing. So we're talking about R.
I have a class together.
Okay.
Environmental engineering.
Okay, so you know something. Environmental engineering. Which
So
department?
I did my PhD here about 8 months ago.
Math department.
I also started position in the library, so I work with Amy. And my focus is kind of data analysis. So helping researchers, support. So supporting researchers, faculty, staff, students, do whatever they need to do. So I'm kind of like
Are you using SAS or SCADA?
Are you state and
well, my focus is R. That's my main tool for kind of conducting my own stuff.
Somebody
Located.
Right. Yeah, I definitely think that psychology is leading the way in this discussion. And the person who founded, she's going to talk about the Open Science Framework, and the person who was one of the founders of the Center for Open Science that developed that tool. They're from psychology.
Yeah, and I do the collaborative containers, but I took over some institutions from and trying to backtrack to figure out which data set to use, what decisions they made, very clear. So I'm going to make sure that the company code
So you have used the because you would have access to our institutional repository as well. So there's several options that you could combine together to make.
Okay.
We can talk.
ours under so many projects.
So when I put up that slide, the results of the survey from Nature in 2016 about what are the barriers to reproducibility. The one I highlighted was missing code and methods, right? So what happens when people share their code and methods? We have this study here. It's an informal study. It was just a group of friends that wanted to try this thing out to see whether or not they were able to reproduce papers that did share their code and methods. So raise your hand if you've heard of a Jupyter Notebook before. Okay, so most people have heard about it. Who's used one? You've used one, right? A few people have. So essentially for those that are new to it, it's a way of making someone's analysis more human readable. It's a way of documenting not only what you did, but why you did it. Because what it does is knit together a narrative language, such as Markdown, with your actual code. So you could use Python, you could use R, there's lots of different ways of doing it. Jupyter Notebooks is most commonly used with Python, but you can actually use it with a growing number of languages. But essentially what you have is one document that actually lets somebody execute your code alongside the narrative in the same document so they understand exactly what you did. So this group of people decided they were going to find out how reproducible were papers that were sharing a notebook alongside the actual publication. And for most people that have used notebooks before, you're using it probably to help with that documentation and that reproducibility of your work. So people that are doing this, they're doing it thinking that they're actually going to make it really easy for someone else to reuse their data and their code. But what they found out after searching for all the papers that have these notebooks associated with them, 107 papers that they found, is that it's extremely difficult and oftentimes impossible to actually get someone else's Jupyter Notebook running on their own system. And this was surprising to them, and I think it's surprising to a lot of people that use these notebooks themselves. And the lesson from it applies to code in general. Sharing your code and your methods pushes you along that spectrum of reproducibility and puts you ahead of the game, ahead of a lot of other researchers who currently aren't sharing those materials. So we want to be doing that. But there's other things we need to share alongside those things to actually make them reusable and actually make it possible to execute that code themselves on their own systems for their own purposes. So they tried to reproduce these 107 notebooks. In the end, they only reproduced one. But to be fair, they gave up after 34. They were like, this is taking too long, we can't do this. The lesson learned is actually that we need to be sharing more than just our code. So here are the lessons that they learned. We've sort of used this as a structure for the exercises we're going to do because they went into this naive, and we're going to come out of this workshop less naive, knowing that it's difficult to rerun someone else's methods and that there are certain little things we can do to make it a little bit easier. So one of the things they found is that people are not sharing alongside their publications the files, the data, and all other dependencies that their analysis rely on. With those things missing, it leaves the person that is forced to try and execute that analysis to try and find those materials on their own. Sometimes they might not have access to them. Sometimes it might not be clear what version was used in the analysis, or it could be just be that they don't even know what they're missing. It's not working, and they don't know why. So what can we do? We can organize our research and organize the materials that we share alongside our research for reproducibility. So that'll include archiving the exact versions of the things that you used, right? The exact version of the data, the exact version of any dependencies that you used. For those that aren't familiar with the term dependencies, it's just any sort of material or file that your analysis is reliant upon. So in many cases, when you're talking about code, that will involve things like a library or a package or something like that that you actually have pulled into your code to run it. But it also can mean your data, it can mean any materials that you use. So we can also take all of those dependencies that we can, bundle them together, and include them in a repository that is linked to your publication. This means that people don't have to search them out themselves and try and see if they can identify them, access them. This isn't possible with every dependency, but when it is possible, that's the best practice because people can then know exactly which version it was and get started right away with rebuilding and executing your analysis. So we want to be linking to repositories rather than to individual files. So we want to have everything that someone needs as a best practice, as the ideal state, everything that someone needs to reproduce your figures, your tables in one repository. Some of you are going to be dealing with sensitive information, proprietary data, stuff like that, and that makes it a little bit trickier. Maybe you can't actually put those things in your repository, but the thing to remember is that put in your repository those things that you can, and when you can't, make sure you document enough information for people to understand how they might get access to that themselves, or at least understand what version you used so that they could take the steps to try and get access to that same version as you used. Any questions? Okay. So throughout the slide deck, I've created these sort of like resource slides, which is a checklist of the main topics that we're going to go through in the exercises, as well as some tools that can help support those checklist items and some of my favorite resources to support that section. So this is the section on organization. The three things we're going to tackle with the exercises are to create one repository or directory that holds all our research materials in one place, to organize that repository in a way that makes those materials more easily understandable. So a common way of doing this is separating your data and your code into different subdirectories, although whatever organization system makes sense for your methods would be the appropriate one to use. But generally speaking, when you separate things with an informative folder system like that, you give people who come to your repository the first time some sort of signal about what is in each of those subdirectories and how those materials might relate to one another. So separating data and code for most people is a good way of doing that. Also, an important thing to try out, if it's appropriate for your workflow, is to save your results explicitly. So what that means is you'll have a subdirectory or a folder called results, and what ends up in that subdirectory is a direct function of your data and your code together, and will be always linked. So whenever you look at a material in results folder, you'll know that that is the results of your most recent data file and your most recent code file. And that means that oftentimes that difficulty that we've had going back to our prior research and trying to replicate our analysis was because we're trying to replicate an image that was actually created from another version of the code or another version of the data. And in most people's workflow, that link isn't documented. So by simply having your results saved explicitly in a results file helps to keep in the best practice of always connecting your results to your most recent version of your data and your code. So there's lots of tools that can help you organize for reproducibility. The Open Science Framework is free, it's open source. It's essentially a way to collaborate with other researchers. It includes some best practices like incorporating version control to track the changes to your files. And it allows you to create, structure to your research. So that's one tool you can use. GitHub is one place that oftentimes people will use, especially for organizing their code, but you can also put other materials up there as well. And I'll be using GitHub to organize some of our materials. And electronic lab notebooks for those of you that have, especially wet labs. These can help you organize your studies and keep track of your materials in one place. And CodeOcean also has the code and the data subdirectories built right into it to sort of make those best practices of separating those things the default position for researchers who are using it. If you are interested in trying out an electronic lab notebook, Harvard has this is Carl Brown. Harvard has a great document that compares all the features of different electronic lab notebooks, and so it's a great place to start if you want to try one out. And if you're looking for some really practical guidance on organization and in reproducibility in general, there's a series of blogs by a researcher named Carl Broman, and I highly recommend these as a place to start if you're starting to organize your research, because he's very practical. He goes straight for just the really discrete practical things that you need to do for organization, and it's not long. So I'll be recommending Carl's stuff multiple times because it is a really great resource. Okay, so exercise 2. We're going to create one repository that holds all our related research files together. So our data, our code, any documentation to allow someone else to understand what's in the repository. If you have a Jupyter notebook or an R Markdown notebook, any sort of documents like that, you want them all in one place. So everyone put up your pink sticky. And we're going to create a CodeOcean account. So we're using CodeOcean for 2 reasons. One is the obvious one, is that I work for CodeOcean. The other reason is it's free to use, and it's easy in this workshop to go through best practices using CodeOcean, but all of those best practices are platform agnostic. You can apply them to whatever platform or tools you want to use. If you want to never ever hear from CodeOcean again, then that is great. You can delete your account, and also on your survey form, click that you don't want to receive news from us, and you'll use it for the workshop purposes only. I know it's really important because lots of us have a million accounts and a lot of spam. We want to avoid that. So once you've created a CodeOcean account and you've gone into your email and verified it, there's always somebody who doesn't get that email. So that's why we have this as a separate exercise. Switch to a green sticky. If you have any issues, raise your hand and I'll come help you out. So just so you know, this isn't like a CodeOcean workshop in the sense that we're not going to be doing training on the platform itself. If you are interested in that, let me know and I can always organize something. But we're going to focus on those things that are can be applied to whatever platform you want to use. Anyone else hear that?
Sorry, no, the server's running.
No, we've got a couple people. Always takes a little bit of time for everyone done. Anyone need some troubleshooting? Anyone confused? Just waiting? Some people will need to resend the confirmation email. I don't know why it happens sometimes, but yeah, you're in. You're good? Alright. How's it going? You're way ahead. You guys are good. And you're probably waiting. Oh. Did you get the confirmation?
We have to resend it.
Okay. Okay, you're in too?
Yeah.
We're not there yet. Don't worry about it. Yeah. Yeah, don't worry. This is
student.
Yeah, exactly. You're ahead of the game. Right. We have. Did you get it? Oh no. Not in your spam either. Huh.
I'm sure
You're in.
something is wrong.
I guess.
Okay.
Okay. I just like I don't actually have any other approaches other than keep resending. That's obviously. Do you have another email address you can
Yeah,
use?
it's gonna get a minute and I'll
Okay, sounds good. And you're in. You're good. Okay. So we'll come back to you and make sure you don't get left behind. But for the rest of you, we'll get you started on the next bit. So we're going to, we call these capsules, but for the sake of the workshop, I'm just going to refer to them as repositories because that's what they essentially are, in the sense of like a Git or GitHub repository. Just meaning this is a folder or a directory, and we're going to duplicate it. Okay. So if you're in the slide deck, what you want to do is click on this bit.ly link. And that will take you to a capsule or repository called the UC Workshop Example. And it should look something like this. So actually, we've changed our UX, user experience, recently. So there's, some of you will see this when you sign in, which is essentially a Jupyter Lab view, which is our new view. But because most of these slides are using the old view, I'm going to show you this, but you're welcome to use whichever one you want. And if you can't find what I'm talking about, just raise your hand and I'll show you where it is in the new view. But essentially, because Jupyter Notebooks and Jupyter Lab have become so popular and such useful tools in research, we're just going to use, CodeOcean is just going to use their interface to make it easier for researchers to learn how to use CodeOcean. So you want to go to this capsule, and then you're going to click on this 3 dots here, and we're going to hit duplicate. And you'll know you've done it right when it says copy after the name. Okay? So put up your pink sticky. And once you have duplicated it, switch it to green. So this is where we're going here. If you're in the classic view, the original view, it's a 3 dot ellipses drop down, and you click duplicate. And the link is on slide 23. Is there anyone that isn't able to get to that bit.ly link? We'll start there. No? Anyone having a hard time duplicating and have a question about how to do it? Raise your hand. No? Okay.
Their email worked.
Oh, that's not good. That's not good. The same email address or use a different email address?
Different. I had an alias I tried, but Gmail works.
Okay.
Although it's not set up on my phone, so now I have to do that.
Sorry, making it real hard for you.
Technology's so great, we're so frustrated.
Yeah. We had a
Okay, perfect.
a
You
lunch
got it.
and learn. I'm wondering if this
And you have a duplicate of the capsule? Yes. And you guys all have duplicates of the capsule? Yep. Okay. So click on that. Yeah. And then you want to
And we
click
did the lunch and learn with the
here.
salesperson and the developer as well.
Click duplicate.
It was really nice.
Oh, you got to sign up.
Maybe that'll be you.
You've done it, yeah. You've done it.
What is the difference between what is the?
So what you've done is you created a copy
Okay.
of your own. So
Where
this
is it?
is the copy that you're in right now.
Ah, okay. Okay.
So the link is to the original. And then when you hit duplicate, it makes your own version of it. Everything's the same.
Okay.
But then it's yours and you can do whatever you want.
Okay.
Yeah.
Ah, okay.
So,
Perfect, you're good.
so then what I have to do?
That you are up to date and we're going to do the next step next. Okay, so everybody has a duplicated version of that capsule. Yeehaw. So yeah, a duplicate it's the same, I guess, as a copy or a fork. It's a way of making your own, taking someone else's work, making it your own, building upon it, trying some things out, and it's all within your own account. It's also private right now. It wouldn't be public until you published it, so you can do whatever you want. Okay, so we all have a copy of that example capsule right here. And in it, this is sort of a skeleton of where we're headed together in the next hour, okay? It includes a Jupyter notebook, some Python code, as well as the data. This is you guys, right? Yeah? No, it's not. No, it's not.
Friends.
Sorry, I've confused you. Ignore what I just said. We're not there yet. This is where we're headed in general, okay? So the next thing we're going to do is create a capsule from scratch. We're going to create a new capsule, a new repository, and we're going to separate our data and code, okay? So in order to keep my actual copy one handy for reference as we go through the experiments, I'm going to open a new tab of the dashboard. So we're going to go to the dashboard and create a new tab. So it'll look something like this. Okay, so everyone put up your pink stickies. By the end of a workshop, everyone's like so sick of me telling them to put up stickies, but I swear it makes things go faster. Okay, so we're going to create a new compute capsule. So you see here, this particular platform, CodeOcean, supports all open source languages and supports proprietary languages that we've been able to organize a licensing agreement with. So currently that's Stata and MATLAB. But we're working on SAS. I know some people in the room use SAS and things like that. For those of you that are going to work through the example code and data with me, we're going to use Python. If you want to try out some other language in your repository, you're totally welcome to. Essentially what we're doing is using what's called container technology, such as Docker. Raise your hand if you've heard of Docker or containers. So a few of you have. For those that are new to it, it's a relatively new technology, 4 or 5 years old. It's very popularly used in software engineering in order to make code portable and to make software development more easily engineered. I'm not a software engineer. But now we can use this same technology to improve the portability of research code. So essentially what it is a way of, say, taking an analysis that you've run locally and works on your machine because of your dependencies, because of your run environment, and all these sorts of things, packaging up that analysis and all those dependencies into a container. So an isolated thing that you can move from system to system, machine to machine, and it carries with it everything that's needed for someone to rerun it without having access to that system, access to those dependencies themselves. So it essentially makes a little box for your analyses to move around. You don't really need to understand more than that, except that there's different services that do it. We use Docker in our backend, and You can use Docker yourself for free. It's an open source tool. It takes a little bit of learning, but the goal of some of these reproducibility platforms that are coming out right now is to make that easier for researchers who aren't software engineers and shouldn't have to learn how to be software engineers just to make the research more reproducible. So we're going to make a Python repository. So when you've created and see this repository untitled code, if you use the Python one, it will say untitled Python code, switch to green. That guy's happy. Alright, we're almost there. I think we're good. Okay. So we have a repository in GitHub that has all our materials in it. You didn't make that, obviously, I did, for the sake of time. If you have your own GitHub repository, you can use your own data and code here. If you have your own materials on your local computer, you can upload them yourself. Because of time, if you want to actually have a functioning executable repository by the end of the workshop, it's probably best to follow along with the example ones because there's always a little bit of troubleshooting with your own. But I do welcome you to try it out with your own and ask me for help if you want. So essentially, we've created a repository on GitHub that has in it our data and our code and a few documents that are associated with it. So everyone put your pink sticky up. We're going to import the data into the data subdirectory in CodeOcean, and we're going to update the code into the code subdirectory in CodeOcean. So there's actually two ways to do this. Whoops, what am I doing? We can upload things locally, just like the way you normally would just upload something into a system. But we also are integrated with GitHub. So let's try this one first. So put into, actually I did that quickly, so let's do this a little more slowly.
In the new interface, where's the GitHub?
What's that?
In the new interface, where's the GitHub?
Oh, in the new interface? Yeah, okay, go to Capsule. And it says import from GitHub. Import code from GitHub. So click that little, it's called an octocat. It's a sort of hybrid octopus cat. And then here we're going to put in that GitHub link that I showed you in the slide deck. It's github/aprilcs/candy_trade. Okay? We'll leave that up for a moment.
Are you in the new interface or the old interface?
Oh yeah, if you're in the new interface.
She's in the old interface.
Oh, you're in the old interface? It's up in the... So that's the data one and this is the code one. So let's do the code one first. Hmm? Oh, sorry, that's for him in the new interface. Yeah. That's one of the problems with having two interfaces live at the same time. I told them that. I was like, I would rather just have us commit to one. And they're like, this is how we do it. They know.
How long is the rollout going to be?
I don't really know.
With ArcGIS, it's like 2 years.
Yeah, it's probably going to be at least till 2019. Yeah. Until like it's bug free, essentially. Yeah. Yep. Oh, so it's actually here that you're going to. Yep. Yep, and then you put in that address there. Yep.
Should we check that?
Yeah, so if you want to, you can delete the 4 existing compute source capsules. If you already did it and didn't do that, don't worry about it, but you can do that if you want, because we'll create our own versions of those things in the very little time that we have left. Amy will tell you that time is not my strong suit. What?
Yes.
Yeah, if you don't delete it, it's okay.
Because they will create another versions of the actually.
We can either delete them manually, or we can update them for our own versions. Exactly.
Yeah, because that's in the original data, that's a pretty big file. So
Exactly.
from GitHub, that's also pretty big. What will happen if we don't do that?
I think that if you have 2 things named the same, it will actually overwrite.
Just override, not create another version.
I think so. It might give you a prompt. I guess, are you doing that?
Not yet.
We'll find out.
Okay, that's fine.
Okay. So I'm going to delete the 4 existing compute capsule files.
I forgot it to use okay, right?
What's that?
I forgot it to use on that one, so not what
So it looks like it's all imported.
Yeah, that's right. I didn't-
Oh, yeah. No, it's okay. It'll still work.
Just override it, no problem.
It overrid it? Wrote it?
override it.
Overrid it? Overwrited it? Okay. So we've got code in here, but you'll also see that we have data because I'm importing, this repository where I put everything in. So, depending on what platform you're in, you might need to do this stuff manually. In this case, you will have to do that. So, what we're going to do here is download this data. Oh, no, we're not. I don't know why it opened. Okay, it's downloading and also opening, but I think it is downloaded. And then we're going to upload it here, and that's because we don't have drag and drop yet. Where are they? Desktop downloads. Here we go.
I have a suspicion that drag and drop is hard to do because open source framework doesn't allow you to do that either.
It's a nice feature, but yeah, I can do it.
Yeah, I think with the OSF it has to do with the different storage areas they have, and you actually have to drag it into not where you would think, but this subsection of it that's OSF storage, Dataverse storage, other things like that. So I think you're right. I think it's not as obviously implemented as some other things.
So all of my code and data
Yep.
and PDF are all in data, not in code.
So your code, okay, yeah, sorry, maybe I wasn't clear. So your code is going to go up here.
And how do we get that up there?
So you can either import it through GitHub if you have a GitHub repo, or you can upload it directly from your computer with this little, I realized that, let's do
I understand. GitHub,
Yeah.
there's 2 GitHubs, one for code, one for data.
Yeah.
Okay.
Yeah, so these are subdirectories.
Okay.
Yeah. So it's just a sort of nudge people towards best practices. If your workflow doesn't actually have data, lots of people don't actually have data, you just put everything in code. If you have documentation that is project level, then you can put it in the code or the data. The code makes sense because if you're reading, from here to here, this would be the first place people would look. You can work with both, exactly. The only thing that you would want to keep in mind is these are subdirectories, so they have paths, right? So this is /code. So let's see, for example, this is /code/candy trade document, right? So one of the things that you have to do when you move things into an executable repository like this is think about those paths. And we're going to talk about that in a few exercises to make sure that you actually can rerun your analysis once you've moved it.
And how do you move the data to the data folder?
Yeah, so you actually have to download it and upload it again. If you want to, you can just import everything from GitHub again and then just delete everything else. But I'm going to delete this. So if you didn't delete the things when you imported from GitHub, these are the things that you want to be in there right now. So you can, if you want, use these action drop-downs to delete them, but it's not necessary. Okay, so there's still some pink stickies up. Is there anyone having some... Okay, if you have your data in one subdirectory and your code in another subdirectory, switch to a
It's a little clunky. So you can run everything in code on data, but because it makes more sense than if you give the data, you couldn't do it. So you, what I think is pull it back again and import it in.
So you can give it a title if you want.
So you have duplicates. And then make the things that everything but the data in the data section. So you can delete everything but data. It's a little...
So I think you guys are good. You're just working through it, right?
Yeah.
Okay.
So I just deleted everything else in the bottom because you already have it up in the code section. Is the actions.
Okay. So we organized our code to separate our code. We organized our research to separate our code from our data. Now we have to think about documentation. So again, here's a reference slide for you. One way of documenting your analysis is to use Jupyter notebooks or other forms of literate programming to explain to a human in an executable way what you did and why you did it. You also have to provide some sort of documentation about each element in your model or each variable in your data set alongside your models and your data sets. So people that come upon them can know, if you've named a data set, for example, happiness level. What does that mean? It doesn't mean anything to someone who isn't familiar with your experiment. So you want to have a document that explains what that is, what are the units, how is it measured, are there natural ranges and limits and thresholds that apply? In our case, the range was 1 to 10. So if someone finds a 50 there, they know there's some sort of anomaly going on in that data set. So common ways of doing that are creating a README file or a data, Common ways of documenting the data is creating a data dictionary or accompanying some metadata in a data repository. Creating a project level README file is a catch-all piece of documentation that can include anything you want that allows someone who comes to your repository to understand what's inside of it, what those materials are in a human readable way, how they might relate to one another, and any other dependencies or instructions they might need to get going and get started with your research. So it's a very flexible document, and having one at your project level can be really helpful in just filling in the gaps between all the other documentation that you've created. You also want to choose a license for your code and for your data, and we'll talk about that in one of the exercises. And ignore the FAIR principles thing for now. I actually took that out and forgot to put that, but essentially FAIR principles are just some standards or some guidance on how to create your research so that it is findable, accessible, interoperable, and reusable. So I'm only saying that because I've accidentally left that point in there and I don't want to have something that's confusing to you. You can ask me if you want to learn more about it. And then the types of documentation we're going to focus in for the last 40 minutes are the computational side. So this is the documentation that will allow someone else to easily execute your methods on your data again. So in many cases, this includes specifying your computational environment, such as not only what languages you're using, but what versions you're using, as well as the package versions that you've used in your code as well as how to configure a container so that someone else can share it, so someone can execute it and use it themselves, so they don't have to have access to that run environment and those dependencies in order to get your analysis started again. So if you're interested in trying out container technology yourself, there's Docker is the most commonly used system for using containers right now. And both CodeOcean and Binder, which is another free service for researchers to configure a container for their research analysis, both of them use Docker in the back end to actually configure that container. And for both of them, you can export that container yourself, the Docker file, to run it locally if you wish to. So anything that you put in CodeOcean, you can get out of CodeOcean, and you know, put it where you want to put it to rerun it. I'm losing my words.
Of some of those Docker files. I mean, I know it will
Right.
depend, but I mean, if you have to include libraries that can be 10, 20 megabytes for each package, and the data can be large, are they easy? I guess the better question would be, are they easy to share based on the size? If the size is not a limiting factor, then it's easy.
Yeah, so actually I think since we're drilling down into the specifics, what you download when you download a capsule is the, let's show you, export. You can include the data because oftentimes data is huge and you might not actually want to spend that time downloading a giant data set, but you can choose to. And then when you save it, it'll zip it all up. And what you'll have is the code in a folder, the data in a folder, and the Docker file, as well as a link to an archive of the Docker image. So this is getting probably more technical than like we want to get at this point, but essentially the file is the recipe, so it's text, right? So it allows Docker to spin up a container, right? So it's not actually containing everything. Everything is archived in that archive. So you can go and it is preserved, but for someone downloading a capsule to rerun locally, Docker will spin up based on that recipe and the dependencies that are there that are not the archived ones, will be able to do it locally. So I think that is probably not enough information for those of you that are new to this, but for those that are thinking about containers already, I'm happy to talk more about the details later. But generally speaking, it's enough to recreate it, but we also archive the full image. So like everything in addition, in case, you know, Seacran or Anaconda or whatever disappear from the planet. Which seems unlikely, but it's not impossible. So I'll show you. Because it's important for reproducibility to be able to get your work out of whatever platform you're using. You see here the data, the code, the environment, and the metadata, as well as a markdown document that explains how to get to the archive of the image.
So, but then you would have to use CodeOcean.
No, it's a Docker file.
Okay. Well, talk later.
Yeah, no, it's a public registry. It's a Docker. It's the Docker's registry. It's like Docker Hub, right? The archive is not archived at CodeOcean. Good question. Okay. But again, I'm going a little slower than I probably should be. So if you are interested in understanding more what's happening in the back end, you can look into some of these resources. But the core of it is that you are creating a container that you can then download and share, or you can share the link to the CodeOcean container itself if you want to share it with people that way. So when people are publishing their analysis, there's no way to directly express the dependencies of the code within the code itself, which is why you need to think about ways of expressing those dependencies otherwise. So there's different ways to do that. One is we can publish the containers that contain them instead, but I'll also show you how to create a standard requirements.txt document, which is essentially another way of expressing those dependencies that can move. Different systems use the same structure and file in order to spin up containers, or at least be able to look to see what versions of dependencies you've used. So the next thing we're going to do is configure the run environment for our container. We're going to use CodeOcean for this, but you could use Docker if you wanted to do this with the actual underlying technology. So what we're going to do is set our base environment to Python 3 with Anaconda. So everyone put up your pink sticky. We're going to go into this environment tab. If you are using the new version, you're going to go into the reproducibility tab, and you'll see a link there for dependencies and run environment. Okay, so we're going to click on that, and then we're going to go to, the default in this case is actually Python 3 with Anaconda, but you'll see that there are lots of different versions of Python. Some versions will break code and some versions won't, but why it's important to use the version that you use when you run your analysis is because sometimes it will actually change the output and the results without breaking your code, and then you have reproducibility issues that you don't even know about. So it's important to have a sense of what versions you're using. So we'll use version Python 3 with Anaconda, Miniconda 4.3. So once you've done that, switch to a green sticky. You have a question?
Yeah.
Yeah.
I don't know how to get it.
Yeah, so it's environment, ENV. This one, this here. Are you in this view?
Oh, yes. That's right.
Yeah. And then it's this drop down.
Okay.
Whoops, not PyTorch. That's not what I want. Okay. We've got some pink.
So this is the default one.
Yeah, it is the default in this sense, in this one, yeah. Yeah, you're good. Oh, I think you are in the, you're not in the new capsule. Did you create a new capsule?
That's a comment. So
Oh, I see. So we've created a new one as well. A new, like from scratch. Yeah. But this is okay because this is actually what we're just about to do. So definitely, you're just ahead of the game. Okay. So the next thing we're going to do is to specify our packages and dependencies with their versions. So these are the libraries and packages that we used in our code, as well as the version number. So if you are doing this and you don't want to use container technology, there are shortcuts to saving this information into its own file that can accompany your research in your repository. One way of doing that is creating these requirements.txt files. I believe, where's the original one of, let me see. Yeah. So if you actually run the example that you copied, that we configured earlier, you'll see in the script here that I've saved all of the dependencies into this file here, requirements.txt. This is what it looks like when it's done. So this is a nice way of doing it if you choose to not use any container technology, because you are sort of automating the documentation of your dependencies in a way that is not only machine readable, but it's also human readable, right? These are the names of the libraries, and then these are the versions. So it takes a long time, but someone could, in theory, manually put together my analysis again. So this is just to clarify, because I switched modes a little bit here. This is the example I asked you to copy. And when you rerun it, this is the output that you get.
It's different. I don't have the same code.
In the example that you copied,
It's something about hello code also.
it's not the. Here, I'll come check in with you in a minute. Okay? Yeah. Okay. But in this case, we're going to configure a container with those dependencies in it so that someone doesn't even need to manually recreate that environment. They can just execute the container. Okay? So how we're going to do that is we're going to install Jupyter, NumPy, and Pandas. I've started calling this NumPy because I went to a workshop and that's where the person called it NumPy, so I don't actually know which is appropriate. But we'll call it NumPy because it's like Python, right? So Jupyter, NumPy, and Pandas into the Conda installer. So everyone put up your pink stickies. Go back into this one that we're creating from scratch. So we're not in the example one that we copied. We're in the new one that we created from scratch. Okay? And we're going to add down here under the Conda installer, so click which installer. That's just the source of your packages or your libraries. So when you are writing some research code, you might be using Cran if you use R, right? You might be using Conda if you use Python. It is good to keep track of what your installer is, just because occasionally you will have the same version number from two different installers differ slightly. So you put in a package name, in this case Jupyter, and click Add. And it will update, it will install that package with the latest version. If you wanted to, I'm going to delete this for a second, and there was a specific version of it that you used, you can put that in here. And that will upload that specific version of the package. So next we're going to put in NumPy, the latest, and Pandas, the latest. So once you have added Jupyter, NumPy, and Pandas, switch to a green sticky. Okay? I'll check to see.
It installs the latest version. And if you know that you have.
So yeah, that's the. That is the code for the copy one. Did you download it? Oh, I bet you were in the example. You downloaded it from the example. It's okay then. Because yeah, it's okay. Okay. A mystery, yet it's okay. Okay. How are people doing? Is there anyone that's like completely confused about what these packages are? I mean, you're new to coding. Were you familiar with libraries and packages? No. Okay. So essentially, these are little. They're useful bits of code. The people, they use it commonly, so they thought it was worthwhile to actually put it together in a little package and share it publicly, so other people can pull it in and use it themselves. So instead of like having, bringing in other people's code, you actually call in an actual name of the package and the version, and then your code can use that code. So it's a dependency. It's a little bit of code that your code uses, oftentimes written by someone else, oftentimes updated regularly, as, the language changes, or maybe the methods change, or things like that. They're often open source, which means that communities can collaborate on them to improve them. So they're really useful. But because they keep being updated like this, if you create some code, and then 5 years later try to rerun it with a package of the same name, you might end up not being able to rerun your code because that package has actually changed. So that's why it's important to know the version of your packages and libraries that you use. So I think everybody is here now. So that's an important part of documentation. We're going to not actually create our own README and data dictionary today because of time. And also, it's not very much fun to document, fake data that you made for a workshop. But generally speaking, a README file in your repository will tell people what other materials, here I'll show you an example, what other materials they can expect to find in that repository. Here's an example of a repository that accompanies this paper in the American Journal of Political Science. So all of the materials are in here, in this repository, and they also have a README file. And what you want your project level README file to have in it, at the bare minimum, is a general description so that someone who finds this repository for the first time can have a sense about your research to know whether it's useful for them. And then you want a file overview. What are all the materials in this repository? For example, here are all the R scripts, here are all the data files, and a human-readable explanation of what these materials are and how they relate to other materials in your repository. So you'd also include things like ranges, units, things like that. You'd also want to refer to all your code books so people can find the documentation, so code books or data dictionaries so they can find the documentation they need to make sense of your work. And then this is another way of addressing the dependency issue. If you were confused by my requirements.txt code, if you aren't quite sure how to do the documentation of your dependencies within the time frame that you have, you can take those package versions, list them by name with their version number in the README file. It's not best practice, but it's good enough practice, and it actually puts you ahead of the game with a lot of people who are just sharing their code without any sense of what the actual dependencies are. So it is an option for people that you're just about to publish, your PI said, no, we don't have time for you to figure out requirements.txt or configuring a container. You can do this instead. So in the slide deck, you'll see my favorite example of how to create a README or example README, as well as for a data dictionary, so the documentation of your data that you should put alongside your data set. Okay, so automation. This is an example of one of those best practices that I was talking about, where if you want to look for what you're going to implement in your next project in terms of reproducibility, the importance of selecting the things that will benefit yourself first. If you are doing some of the same things over and over again in your research manually, that is not only time consuming, but it's also a barrier to reproducibility, because if you're doing something manually, you have to put in really rich documentation to allow someone else to reproduce that manually themselves. So for example, it's pretty common practice for someone to share an Excel spreadsheet of raw data and then to clean it up manually. If you want to be sure that someone else can move from that raw data to some sort of analysis data, and you're doing that data cleaning manually, you have to write a page of and then you renamed this variable this, and then I checked it for these ranges and blah, blah, blah. And you're going to spend a lot of time doing that documentation. You probably won't. And if you're doing the same sort of thing over and over again, automating it will not only save you time in the long run, but it will also improve the reproducibility of that step. So anytime that you find yourself repeating something, see if you can write some code to do it or get some software to do it, and then record that process and share that code so that other people can easily replicate that step. If you're not a coder yourself, this is the sort of thing that is worth your while to find someone who can help you with it. A lot of researchers aren't coders, and they're not, going to become software engineers, but there's usually someone in the department that can help them out. And this is a bit of code you can reuse, so it can really save you a lot of time. So the 2 points of automation that we're going to talk about are the paths. So we talked about how when you move your data off your local machine or some other machine into a container or onto someone else's system, that those paths to your materials, to your files, might be what are called absolute paths. So what that means is it's pointing to a specific place on your machine that might not exist on someone else's machine. So one way of automating your code so that it is portable, so that it can be rerun just with the click of a button from one person's machine to another, is by creating relative paths. So we're going to do that with our code. The other important thing to think about is, especially if you have multiple scripts that are running together from your raw data all the way to what you've published, you want to be sure that someone knows what order those go in, or if there's something that you're doing across multiple files, one at a time, to ensure that people know how to apply those things. And the way of addressing that in terms of reproducibility is by creating a master script, also known as a driver script. And so this is essentially just one bit of code that runs all of your other code. It tells somebody exactly how to get from the start to the finish. And this is a really important step in reproducibility because oftentimes people have all the materials that they need, but some of their code is reliant on other bits of their code and it needs to be run in a particular order or it won't work. Or even worse, it will give you something, but it's not the right thing. So a master script can be a very simple thing. It can be just the order of those scripts that need to be run. But it's actually a really important step towards computational reproducibility. So we're going to write one of those as well. So yeah, there's the best way of automating the reproducibility of your work is to configure a container like we talked about before, and to make sure that our analyses are portable by dealing with our paths. So again, Carl Broman has great, very practical steps on this. He talks here, you can see, about relative paths. So here's an example. This is a relative path. So you'll see a ... and then something like data or code. In CodeOcean, we already have the subdirectories set up as data and code. So that's how we want to go through our paths in our code and make sure that those are appropriately assigned. And what we often have when we upload things to a platform or a repository is something more like this, where it's projects or desktop or users and things like that. So it doesn't take a lot of time necessarily if you have only one script for someone to change that, but if you have multiple, then what you can do is in your master script, you can actually look for a certain path, and every time that the computer finds that path in your code, it automatically changes it to this. Does that make sense? Okay. So, yeah.
In layman steps.
Yes.
When you put those ...
Yes.
It will search your computer for the rest of the file names.
It'll search the work environment that
Work environment.
Yeah. So if you're using a repository like this, you'll have a subdirectory of data, a subdirectory of code. If you put ... /data, look for a data folder. Yeah. And it should work. So when they were trying to reproduce these Jupyter notebooks, they found that there were many steps that were manual, that weren't documented, and they were left in the dark to try and figure out how to get someone's data and code running and how to reproduce the results. So we're going to automate the execution of our analysis so that people don't have to try and figure that out for themselves and limit the number of manual steps someone needs to take in order to reproduce your analysis. So first things first, we're going to create a master script to execute our code. So put your pink sticky up. So we actually have in our example that we copied a shell script that should work for the code that we've uploaded into our repository that we created from scratch. Okay? So for the sake of simplicity, we're going to copy and paste it, but I'll explain to you what this particular run script does. Okay? So copy this run.sh script. Go into the repository that you've created from scratch and click on this create blank file. Okay? If you've deleted all the materials that were there before, then you won't have a run script in there anymore. If you didn't, you will, and you can just delete that content and replace it. This is the problem with having people with different setups, but exactly. Exactly. So we're going to create a blank file. We're going to call it run.sh, but to be honest, you can call it anything you want. You could call it main.sh. Sh just means it's a shell script. But for our case, we're going to call it that. Copy and paste this shell script in here. So what this says is, I have a Python script named this. Run it first. I have a Python script named this. Run it first. Then freeze all of my dependencies into the results subdirectory and call it this. Right? You could also do it for Conda if you wanted. So this means if you installed through pip or you installed through Conda, but you don't have to worry about that right now. Also, I have a Jupyter notebook in here. I talked about before this type of knitting together of the narrative and the analysis. So this just says we want to convert a Jupyter notebook into an HTML file and save it in our results. So that means it's executing the whole notebook, which is a bunch of code from start to finish. So all of the narrative is alongside all of the images and outputs, so someone can just read it. And the nice thing about this is they're going to read it, and they're actually going to know, because of this run script, that Jupyter notebook is the direct execution of the notebook that is named here and executed here. Does that make sense? So remember how I said you want the results to be a direct function of your data and code? That's an example of this. So once you've added a run script into your repository that you've created, switch to green. If you're having trouble, raise your hand. Yep. Where I got the text from? Yeah. So did you copy the example one at the beginning? Okay. So do you have the slide deck open? Yes. So go to the dashboard, and you create a new capsule. Oh, you mean create a new file? Oh, yeah. Okay, yeah. So go back into, I think, is this one that you're working on? So it's this. That one, yeah.
This is a folder.
Yeah, yeah. I know, it's, no, the next to it, they're very small, it's very confusing. It's,
Thank you.
the icons are being improved.
I think there's a question in the back.
Oh, there's another question? Yeah. Hi. And you have the, did you copy also the example repository folder? So close this out. Open a new tab with suggestions. So let's click on it or pull it. Go here. Go to the room script and copy that. Go back to your dashboard. Refresh these. And go to the new one that you made. There you go. Okay. Okay, so you already have one, so that's great. So cancel. And replace all of this with a user. Okay. Anyone else? Okay. So the next thing you need to do, click on Actions next to your run.sh and set it as the main script. So main script, driver script. It's confusing to have so many names for it, but it's essentially, this is what is running when you hit run.
I have different watch files with yours, so then I think this is them I connect them from the watch file.
No, it's a,
That's why it's a how I'm going to
click on new.
So if I can just create a other than having it already.
Yeah, so go into your dashboard again.
That's okay.
And see this example here, go here.
Oh, okay.
Go into that run.sh.
Oh, okay.
Copy that.
That's it.
Yeah. And then go back to your dashboard. Entitled Other Code, I think, or entitled Python, which one? There's several. Okay.
Oh, maybe this is
Let's try that one.
yeah. maybe
And
that's
then, yep, and put it in there.
Excellent.
Great.
So
And then you
the
set
role-
it, click on this here, and then click on Actions, set as main.
Oh.
Yeah.
I'm gonna put out.
I only can run, for example, I have two. I only can run main if I one of the two codes. If I to run, for example, run as this one,
Mm-hmm.
I have to choose first like a main, or I can. There are another way to choose what code I want to run, or is always have to run the main.
Yeah, you always have to run the main.
Okay, so
Yeah.
I first I have to choose what is the main, and then I can run.
Exactly.
Okay.
Yep.
Okay.
Yep.
New interface, set of master script to, okay.
Maybe because it's already selected, because it's got the flag next to it.
Fix something else in there. So it's,
So it won't let him mark down 1B. Yeah.
okay.
So it's because it's already set.
All right,
as
thanks.
master. Yeah. Okay. So the next thing that we want to think about are the relative paths and absolute paths. So the code that we've uploaded actually already has them already switched to relative and absolute, but I just wanted to show you what it looks like. So it's not actually an example, but you see here this /results requirements.txt, the example of a relative path as opposed to, say, desktop, whatever, right? So when you move your code from a local system to a repository that you would like to accompany a publication, you want to make sure that you've changed all those. And like I said before, one of the ways to do that is to actually do it within the master script itself, so it will search through your code and make those changes automatically. What are we doing? Okay, so we now have a repository. We've got a container configured with all our dependencies, and we want to associate this with a publication, because this is the materials that turns our article from an advertisement to the actual research, at least in theory. All of us are going to probably, approach that a little closer every time we publish. So if you can only do a few things, that's okay, like I said. One best practice for associating a repository with a published paper, if you want to use Binder, is create a GitHub repository of all your materials. It's free. Create a Binder file that you would attach into the repository. They have a lot of great documentation to explain how to do that. So that creates a container for people to use. Then you use a data or code repository that preserves things, such as Zenodo, which is also free, to get a DOI. A DOI is a persistence identifier that you can link into your paper, and then people can click on that, and they will see an archived version of your repository with Binder, and it'll make it much easier for them to get your code going. Another way is if you wanted to use CodeOcean, you actually can get a DOI for your whole capsule, your whole repository that you can publish alongside, and people can come for free, click run, and rerun it themselves. Okay? So because we're kind of at the end, I just want to show you quickly the metadata tab. When you create a repository and share it alongside your article, you want to make sure that you include some rich metadata. And this is a good time and place to reach out to your library and find somebody who can help you identify what the metadata standards are in your discipline. But basically, you want to ensure that you at least have your license information attached to your data and code that tells someone else who comes to your repository how you wish for them to attribute the work, so if you want to be cited for it, and what they can do with it. So these are the defaults that we currently have, or an open source license for your code, and a data license, a CC BY. But there are lots of options here out of the box, and you can also upload a license.txt file for a custom license, or pick whatever license you want. But it is important to add a license, because many people who want to reuse your research will only do it if they know exactly what they're allowed to do legally with it. A lot of studies will just exclude everything that's unlicensed. Even if you assume that they'll use your work, they might not. Okay, so for the sake of time, I'm just going to show you what we've done. This is always a risky business, clicking run, and it may or may not work, because there's oftentimes typos that would be totally my fault. Let's see. All right, here we go. Let's see. So this is an executed Jupyter notebook, so you can see people can actually read about the analysis that we've run. They can understand, what does pre-trade mean, trade one, how are these things coded? I have this in my code, what does it mean? What's the form we used? Here's the raw data. That's us, right? Yeah. And here you can see some people got really unhappy at some point. In the candy shade, you got less happy. That's bad. But overall, we actually increased our happiness by the end of our workshop, so that I consider to be a success. So if you do want to learn more about this Jupyter notebook thing, there's we're starting to run Jupyter notebook specific training. So let me know if you're interested in that. But essentially, this is what a Jupyter notebook looks like when you are making it locally. We have these interactive sessions where you can spin up a Jupyter notebook through CodeOcean and play around. We're at time right now, so I'm going to stick around for another half an hour or so, but I just want to say thank you for coming. Feel free to ask questions, but for those of you that are on a schedule, I understand you'll have to probably leave. But please consider giving me some feedback about things that you would like to see improved in the workshop, because I take all of that and I update the curriculum with every time that I run it. So you can see here, this is a Jupyter notebook. It will go as fast as the Wi-Fi will allow. Any questions?
So what if I would like to modify my code because I found something wrong, and what is the better way? I mean, just modify on the CodeOcean, or I have to modify locally and upload it?
So you can modify it in CodeOcean. If you click on the bit of code that you want to edit, you can edit it right within there. But best practices at this point, since we don't have version control yet in CodeOcean, would be to use GitHub or another type of system for uploading your code and then bring it into CodeOcean again, because we're currently optimized for publication. But we are integrating with Git. That should be within the next few months, in which case it would be totally appropriate for you to actually develop your code on CodeOcean. Right now, that's not really the case. Yeah, so this is a Jupyter notebook. So you can execute cell by cell. Anyways, I just wanted to show you what I was talking about for those that are new to the idea of a Jupyter notebook.
On your DOIs that CodeOcean provides, do you make the DOI point to something that's static then? Or can people then go and re-edit that, and the DOI then points to the new version?
So you can do versioning. So, but the DOI will be, a new DOI will be minted for each version. So
every time, if you just go in and edit your capsule, it'll automatically produce a new DOI?
Not if you edit it. If you edit it and then publish it again.
Okay.
So if you just edit it, you will have, the changes will be locally in your own sandbox and not public.
Okay.
Right? But the public DOI record
It does stay frozen.
will stay frozen. Exactly. So for those that want to see what the versions look like. I'm not offended if people get up and leave. Sorry, I'm just answering questions, but if you've got to go, please.
I guess just before everybody heads out, thank you so much, April, for this workshop and taking care of this and providing the food that you brought with. And if you haven't signed the attendance sheet, please make sure you do, even if you registered. This way, we are thinking of doing a pilot with CodeOcean, which would allow much more access to the platform than just what we would have through our academic status. So you would be people that we would be following up with about the pilot to let you know. So please just make sure you sign in if you haven't done so already.
Thanks again, and thanks Amy for helping to organize everything. It's been a real pleasure. And when you fill out your surveys, if you're generous enough to do it, it will talk about reproducibility consults, which are essentially just phone calls with me if you have specific questions about your own research, as well as a reproducibility ambassador program, which is for those people that are interested in talking about reproducibility with colleagues. We can help you, we can support you, we can buy you pizza so that people will come. But we also have a travel grant program, which is one of the first things that we're launching in the ambassador program. So if you're interested please let me know. Thank you.